Hi guys, welcome back to my channel. Thank you so much for clicking. So today we're going to look at the practical part of CCNA1, that is Introduction to Networks, the Packet Tracer task. So as you can see, I've already covered all these modules. They're the notes, the materials, plus the exam of each of the modules. So today we're going to handle this part, the final skills exams, which is ITN final skills packet tracer task assessment, right? So let me click it. Okay, so the first time I took the assessment I got 80%, and now I'll click on retake the assessment, and I'm using the latest version of packet tracer. So let's just give it time, and I open packet tracer executable, and I'll pause the video so that I return when this one is finished. Okay, so we may begin our task. As you can see, so this is the task that we want to implement. On the right side you can see the topology and the instruction that we've been given, and on the left side there is a topology that we've been given and the instruction to implement the topology. And on the right side, as you can see, we've been given the networking devices plus the cables. We have two PCs here, and let me scroll the rightwards. You see we have a router here and a switch. Okay, so let's start reading. So this is the topology that they need us to implement. So I'll just go this way. You will receive one of these possible scenarios. In order to use this logical topology diagram that is provided with the instruction, use the device name in the table below. Okay, so the topology diagram name and your scenario name. Okay, and so addressing requirements is here. Network address is this one. Okay, LAN 1, it has 29 computers or host devices, and LAN 2 has 17 devices, and the interface the interface of router 1, which is gig 001, should take the first IP address of the LAN 1 subnet. Okay, and the gig 000 should take the first IP address, the first host address in LAN 2 subnet. Okay, and basically in a switch we should have the switch virtual interface should take the second host address in LAN 1. Okay, alright, so PCA should take the last host address in subnet in LAN 1 subnet, and finally PCB should take the last host address in LAN 2. So basically, before we may proceed, guys, because I know from the task there are some instructions. So before we may proceed, I'll open Notepad to do some simple subnetting. Okay, so the network, we've been provided with a network of this one. Okay, a network of that one. Then we've been told LAN 1 should have 29 host devices. Then LAN 2 should have 17 devices. Okay, so basically, guys, what we are gonna do is to subnet. Okay, alright, so for LAN 1, how do we find the number of hosts? 2 raised to power n minus 2 is equal to, for LAN 1, let me just say LAN 1, okay, is equal to 29. Okay, 29, right? So this one will be equal to 2 raised to power, where is the raised to power n is equal to 2, return this side would be plus 29, which is 31, is equal to 31. Okay, so n represents the number of host bits. Okay, this is a method of calculating the number of hosts in a network, and we've been told that in LAN 1 we have only 29 devices. Okay, so 2 raised to power n minus 2 must be equal to 29. So we must find the value of n. The value of n will tell us how many host bits are there in the network. Okay, so which value that if we place here will give us a value which is exactly 32, exactly 31 I mean, or slightly more than 31. So let's start. 2 raised to power 2 is 4, 2 raised to power 3 is 8, 2 raised to power 4 is 16, 2 raised to power 5 is 32. Okay, so n must be 32. Sorry, n must be 5, because 2 raised to 5 will give us 32, meaning all the 31 hosts will feel accommodated. Okay, alright. So you know, here we have been given that the subnet mask is this one. So I'll just say, when you convert this prefix into binary, it will become 111111. That's 8, 1, 2, 8. Then paste dot 1 2 3 4 5 6 7 8. Okay, so this is the prefix for the network that we are given. Okay, but now during subnetting, the subnet mask should change to accommodate the number of hosts that you need in the network to avoid the wastage of addresses. So for LAN 1, we've said that the number of n should be 5. Okay, remember, in this binary, all the ones represent the network portion and all the zeros represent the host portion. So we've been told that the host portions have only 8 bits. 5 bits, meaning the new subnet mask will be, let me copy that, 1 2 3 4 5. Okay, so this one will be the host bits in the new subnet mask, meaning the remaining 3 will be ones. Okay, so just say 1 2 3. Okay, alright. So this is our new subnet mask. So if we convert this into decimal, it will become 255.255.255. If you convert this into decimal, the here always represent 128, this here is always represented by 64, here 32. Okay, so 128 plus 64 plus 32 will give us 224. Okay, so this is our new subnet mask, which is equal to prefix 127 I mean. Okay, I hope you understand the simple concept. So for LAN 1, the network will be this one. Let me just copy all of it. This one slash 27, because after subnetting we found that the prefix should be 27, right, to accommodate 29 hosts. Okay, alright. So we proceed to LAN 2. So guys, there's a concept of block size. Okay, how do we move? The block size tells us, guides us how to move from one subnet to another. And how do we know where the block size is? The last network bit. This last network bit, which decimal value does it represent? It represents 32. Okay, because from here is always 1. 2 raised to power 0 is 1, 2 raised to power 2 is 2, 2 raised to power 2 raised to power 0 is 1, 2 raised to power 1 is 2, 2 raised to power 2 is 4, 2 raised to power 3 is 8, 2 raised to power 4 is 16, then 2 raised to power 5 is that one. And another way to calculate it, the first value is always 128, then we follow by 64, then 32, then 16, 8. You start by 128, then you divide it half until you reach 1. Okay, so the last network octet, the last network bit, the last network bit that is turned on as a value of a decimal value of 32. So we had 32 here. Okay, sorry, so for LAN 2, the first network will start from, this is the network address, because the block says you move from, this one tells us that if you convert this into decimal we'll get 32. Okay, and the block says basically tell us how to move from one subnet to another. Okay, alright, so guys, we need to design another prefix for LAN 2. We've been told that LAN 2 has how many devices? Only 17. So let's calculate. I'll just copy this one so that we can design another prefix for this one, subnet for that one is equal to 17. So which is I'll copy these two so that we can calculate. Okay, alright, now this one will be 2 plus 17 is 19. Okay, and I'll delete this one. So 2 raised to power 1 is 2, 2 raised to power 2 is 4, 2 raised to power 3 is 8, 2 raised to power 4 is 16, 2 raised to power 5 will give us 32. You know, we can say 2 raised to power 4 to accommodate 19 host devices, because 2 raised to power 4 will only give us 16. Okay, so it must be 2 raised to power 5. Okay, that will give us 32 host devices to accommodate 19 devices. So that one will be 5. So it's the same as here. So I'll just copy this one and give you an explanation a little bit. Okay, so this was the normal subnet mask. Okay, here. Okay, and we've been told that after subnetting the host bits are 5. So we start counting from here. Host bits are always represented by zeros. So here is 0, 0, 0, 0, 0 until we reach 5. So these are host bits here. Okay, and now the remaining one should be ones. Okay, and if you convert this into decimal, you find this one, then into prefix you get this one. Okay, alright, so before that let's find valid host addresses here. Okay, so the first valid host address will start from 1 to 30. Okay, then broadcast broadcast will be 31. Okay, the broadcast IP address is always the last IP address to move to the next subnet. Okay, alright, copy, then we paste here also. The first valid host ID will be 33 because this is 32, that's a network, so it's 33. And the last host ID will be 33 plus 30, will be if you add another 32, that will be 64. Then the next subnet will be 6, starting from 64, and then broadcast ID will be 63, and now the last host IP address will be 62. Okay, 62. So let's go back and see. Alright, so let's see the task. A few things: do not use the browser button or close the reload button. Do not close Packet Tracer when you are done. Click the submit. Okay, those are instructions that we know. So assessment begins. Build the network, develop an IP addressing scheme, configure basic device settings, configure security settings on router 1 and switch 1, configure the host and verify connectivity. Okay, in the assessment you will configure router 1 and switch 1. You have done in the activity in the course. You will connect two PCs using the switch that are in the main wiring clone set. Okay, you will subnet that one for two subnet that will support the requirement. Okay, the larger subnet requires that one and that one. Okay, all right. So build the network topology. Build the network topology according to the wiring by placing the required equipment in the wiring closet equipment rack. Cable the devices in the closet as shown in the topology. Connect the hosts as shown in the topology above. So let's start. We are required to drag these router. Just drag them there first, then we drag them to the rack. Okay, all right. So as you can see, we have them there. This is the rack, right? As you can see here, we've been told wiring closet equipment rack, and this is the rack here. It's written here. Okay, all right. So wiring. So to do wiring, the first thing we'll first see the topology here. We must connect PC1 to F06 port on the switch. So to connect PC to switch, you choose this one, straight through cable. That's PC1 here. Connect there to which port of the switch? FA0/6. That one. Okay, another part, you connect FA0/5 to gig 011 of the router, 001 of the router. You still use straight through cable. So it's gig 05, that one, to gig 01. Just a minute. Yes, and finally gig 002 PC2, right? So you still use the straight through cable. Just a minute. Yes, to PC2. Okay, guys, so basically, guys, let me show you something. Basically, if I click on this PC, as you can see, I'm getting this error. So let me close it. But if I click this switch, as you can see, I'm getting to the CLI. And also if I click the router, I'm getting the same error. Okay, why? You know, most routers, let me just say, the routers and the PCs, the computers, they always have a power button, and you must turn on first before you can operate. Okay, where is the button for the PC located? Do you see something here? Do you see something here? Something like a circle and a minus. Okay, just click on the circle and the minus will disappear. Also come here and click on the circle and the minus will disappear. Then click it again. As you can see, test this one also. As you can see, that's done. Then come to the router. Also the router has a button, but now to locate the button is the difficult point. I'll show you where the button is. Somewhere here. There is a button there. There's a button there that you can turn on and off. So what you do is just to click it and test. So I'm just trying to click it and test if we can go to, as you can see, device still booting. Please wait until it's finished. That means we have clicked on the right button. So just make sure, as you can see, the router is booting. Just make sure that the button is here. You click somewhere here, and when you click one, test, because you know it's invisible. It's so small. Okay. All right. So I hope you've understood how to turn on the devices and I will go develop an IP addressing scheme. We have done subnetting just a few minutes ago. Okay, our subnet calculations are here. Okay, so record your subnets according to the following subnet. Okay, assign the first IP address to the router interface. Okay, so for gig 01 should be assigned the first IP address in LAN 1. Okay, as you can see. Then gig 00 should be assigned the first IP address in LAN 2. Okay, then we also needed to assign IP address to the PCs. Okay, and finally the second IP address should be sent in LAN 1 should be sent to the switch virtual interface. Okay, so let's do that one very fast. I'll click on the router and say enable config t conft. Okay, just like that, and you say interface gig 0/0/1. okay, this one should be assigned the first IP address in this LAN, then this one first IP address in this LAN. Okay, all right, so I'll click and say enter. IP address should be this one. The first valid host should be this one. So I will copy and come and paste. Okay, and the subnet mask will be 255.255.255. Guys, don't forget here the new subnet mask was this one. Okay, .224. okay, 224. okay, then you say no shutdown and you hit enter, exit. Then another interface which is gig 000. Just click on the arrow up, arrow down to see the what you configured above. So gig 00 should take the first IP address in the second subnet, which is the second subnet has the first IP address should be this one .33, and the subnet mask is still this one prefix 27. Okay, all right, so what I'll do, I'll change this one to 33. Okay, very simple, guys. Hit enter, no shut, exit, do right. So we are done assigning IP addresses to the router's interface. What I'm gonna do is to assign IP address to the computers. We've been told that the computers should be assigned the last IP address in the let me just show you. Assign the last IP address of each subnet to the PCs. Okay, so I'll click this one, and that's PC1, and the last IP address was this one. Okay, and I click here and say that one. Don't forget subnet mask. Subnet mask was .224, right? And the default gateway should be the IP address of that PC, of that, I mean the IP address of the router's interface, which was gig 001, and it was .1. Don't forget that one, guys. Okay, as you can see, PC1 was connected to the switch, and the switch was connected to the router. Okay, as you can see here, I'll just show you here. Okay, so the default gateway of this PC should be the IP address of this interface, and now the IP address of this interface should be the default gateway of this PC, right? Okay, now for the PC which is in LAN 2, now the last IP address will be this one. Okay, then paste. Don't forget the subnet mask, which was 224, and now the default gateway should be .30, not 30, but 33, because the first level lead was 33, right? Okay, so I believe we are done. Just close And now another point is on the switch. Assign the second IP address of LAN 1 to switch virtual interface. What's the second IP address of LAN 1? LAN 1, we have the first IP address of .1, meaning the second IP address will be .2. Okay, so I'll click and say enable. Now we click on the switch config T and say interface VLAN 1. Guys, when you get this term SVI, switch virtual interface, it's always assigned to VLAN 1. Okay, alright, so the switch virtual interface is the VLAN 1. So you hit enter and you say IP address to be .2, right? And the subnet mask, don't forget, 255.255.225.224, right? Then you say this command, don't forget this one, very important, no shutdown, because by default the VLAN 1 interface, the switch virtual interface, is always in shutdown state, so it's upon you to turn it up. Okay, alright, exit, do that. Okay, so let's see what's next. Configure basic devices. We need to configure, we disable DNS lookup on both the router and the switch, then we configure hostname, then and banner message, and we configure line console password. Okay, so the first thing, I'll just open the notepad and show you how to disable DNS lookup. You say IP domain, you say no IP domain lookup. Okay, you say no IP domain lookup. Okay, no IP domain lookup. Then how to configure hostname, you just say hostname R1 for the router, and then banner message, you write banner MOTD, then you write any character like a hash, asterisk, hand, etc. But I always prefer hash. This is a test router. Okay, and now we need to configure line console. We just enter the line first, line console 0, just then password, we issue the password command, and now the password should be this one. Sorry, copy, issue the password, that one. Okay, and after issuing the password, you must log in that user, right? And you exit the line interface, right? Okay, so we are done. So I'll copy this one first. I believe you understand how to do them. I'm doing them on the notepad so that I can copy them very fast, because you have limited time. No, that is meant for router. I clicked on the router and paste this one. Okay, as you can see, then the default name has changed from the router to R1, and we have entered the line console 0, the password of that one, login, then you exit the interface, then we proceed to the switch. Now switch 1, say switch 1, this is a test switch, and everything remains the same. Copy to the switch and you paste. Alright, okay, do right. Okay, so let's proceed again. Configure these interfaces using addressing on the previous part. We've just done, guys, that we've just done. Oh, what's remaining is to the description of each interface. Okay, I'm going to show you that. You have even configured the VLAN 1 interface and assign it to IP address. So basically what we are going to do is to the description of each interface. Okay, interface gig 0/000, then description. This connects to LAN 2. Okay, then another one, gig 1001, this connects to LAN 1. Exit, do right. Okay, but for the case of IP address and subnet mask, we have already assigned earlier. Hope you remember. So we come back to the interface VLAN 1, description. This is used for remote access. Do right. Exit. Okay, we are done. Step 2. Now let's see what's next. The switch should be reachable from devices on the other network. So let me try to ping the switch. We gave it an IP address ping. Oh no, sorry. The switch had an IP address of let me see, .2, because the second, let me paste this one, .2. Let's just give it time to see if it's reachable. Switch virtual interface. Okay, now it's reachable. I'll close that one and proceed to step part 4. Now we need to configure this one as the encrypted privilege exec password, then encrypt all plain text password, then set minimum password of length, that one. So what I'll do, I'll say how to set privilege exec password. We say enable, and then now we've been told that it's a encrypted password. Okay, so we say enable secret, this one. Okay, so I'll just click on that one and say enable secret, that one, and we need to encrypt all the plain text password. Okay, and here now we say service password encryption. Okay, to encrypt all plain text password, right? And now to set minimum password length on router 1. Okay, alright, now do we say that one? We say security passwords mean length to be 10. Okay, so I'll copy this to paste to the router. This is our router and I'll paste there. Okay, as you can see, they are picked. Do right, and then we need to configure the switch with the same, but for the minimum password we've been told only on router 1. So copy this one also to the switch. Okay, and do right. Okay, so we proceed to step 2, which needs us to configure an SSH on router 1 and switch 1, and the domain name should be this one. So I'll copy this one. How to configure SSH? We say IP domain name, the first command, right? The domain name should be that one, right? And configure local user, this one, and then encrypted password of that one. So I'll copy the password. Remember, this is an encrypted password, so I'll say username netadmin here, as you can see here. Then the password should be encrypted, so we say secret secret that one. Okay, then set login on V2F interfaces to use local database. The first thing we do, we enter that the line interface line V2Y0215, and then login local. Okay, and because we are configuring SSH, it's very important that we include a command that is called transport input SSH. Okay, alright, so we exit that interface. Okay, or then you generate RSA crypto key using this one modules. Okay, 2 or 1024 bits modulars. So I'll say, you say crypto key generate RSA, then you hit enter. I'll just copy this one first so that I can show you. Click on the router and you paste the domain name, username and the password, line V2Y 0215, login local, transport input SSH, and crypto key generate RSS. You hit enter, then 1024 as explained here. Okay, alright, then you hit enter. And another thing, guys, I think that's done. So I will copy the same for the switch. Copy here, go here, and you paste, hit enter. You say 1024, hit enter, do that. Then come to the router again, do that, hit enter. Okay, so secure switch ports on switch 1, shut down all unused port and enter description of each. Okay, so I'll go to the switch, and on the switch, guys, we are only using 2 ports, this one FA06 and FA05. Okay, so all the remaining ones are unused. So I'll say interface range FA0/12 to 4, then you say description, these are unused ports. So I will copy the description part, copy, and you hit enter, and now you shut them down. You just say shut. Okay, exit. And another range should be interface range from 7 to 24. You remember there are 24 fast Ethernet ports on a switch, so and we only use 2, FA0/6 and FA0/5. So 7 to 24 also should be shut down, and you paste the description and shut. Okay, and also there are some gigabit Ethernet ports on a switch. As you can see, gigabit Ethernet 01 and gigabit Ethernet 02. So I'll shut them down too. Exit, and I'll say interface range gig 0/0 0/1 to 2. Hit enter and paste the description and say shut. Do right. Exit. Okay, I think we're done on the switch. Do right. Okay, so what's now remaining? Configure host and verify connectivity. I'll try to ping from this PC to this PC. Remember, this PC had an IP address of let me check. I'll copy this one and the issue here, ping. Let's see. and also that's going through as you can see. So I'll try to ping from that PC to this PC, copy, close that one, come here, ping. As you can see, it's going through. Alright, and now what we need to verify is how to have configured SSH. Remember, we have configured SSH on this switch and on this router. I mean. So how to verify an SSH? You say, say SSH, then -L, the username of those devices. We were told that it's neta admin, then the IP address of the router or the switch, which was the switch was this one, .2. Hit enter. Password, let me see. The password for the SSH was this one. So I'll copy and paste. As you can see, guys, we are in switch interface enable, and now we need privilege exec mode password, which was don't tell anyone. Okay, I'll put that on also. As you can see, config T, we are in the switch interface, okay, from our PC A. So exit again. Okay, now we are back to the PC. Let's try to access the router. SSH, the username was the same. Now the password for the IP address of the router should be, let's check for gig 01, which was let me just click on this PC. Okay, which was .1, as you can see, and the password was let me just, this one, copy, paste, enable, and privilege exec password should be no one should know, don't tell anyone, I mean. Copy, then you come here and you paste. Everything is working completely and as expected, guys. So I believe this video will really help you a lot. And guys, don't close anything, don't close the packet tracer. Just go back to our task here and say submit assessment. Let's see what we've gotten. Okay guys, as you can see now we have 87. That's 7 points improvement, and that's pretty okay. You know, getting 80 and above is pretty much okay, right? And as you can see now the task is 87 point something there. Alright, so if you go to the grades, and you will see that I have really gotten 87. Okay, so guys, I believe this video will really help you pass this practical exam. Please subscribe to my channel. Bye, and see you again in the next video. Bye. Thank you so much.